You know, every time you hit play on a video, you're kicking off one of the most complex, high-speed journeys in the modern world. Today, we're going to pull back the curtain and follow that journey, step by step, to see the incredible, hidden system that brings that video to your screen.
So let's start with a simple question. Have you ever really stopped to think about it? With billions of us watching video online, why isn't everything just a constant stuttering mess? Why isn't that dreaded buffering wheel a permanent part of our lives?
Well, the answer is an invisible high-tech relay race. It's this incredible journey that a single piece of video takes from its source, through a massive global system, and finally, right onto your device. So let's break that journey down.
Okay, to really get this, we have to understand the fundamental challenge. We start with just one video source, let's say a camera at a football game, and we have to deliver it perfectly to millions of different screens, from giant TVs to tiny phones, all with wildly different internet connections.
And this slide really highlights the pressure cooker we're talking about. For something like Netflix, they get the movie file way ahead of time. They can take their time, polish it, get it just right. But for live sports, whoa, the video is happening right now. There are no do-overs. Every single second counts, and the system has to handle this constant, unending flood of data instantly.
All right, let's move on to the first and, maybe the most critical step of the whole journey, the handoff. This is all about getting that flawless video from the source, like the stadium, into the cloud servers without a single error.
I love this quote from the Netflix technology blog because it hits the nail on the head. The entire multi-million-dollar system that follows is completely useless if the video you start with is blurry or glitchy or corrupted. If you start with garbage, you are absolutely going to end with garbage. Everything depends on getting this first step perfect.
So how do they guarantee that perfect handoff? They use a specialized protocol called RTMP. Think of it as a dedicated, high-security shipping service just for live video, reliably packing it up and sending it from the source to the server. If you've ever streamed on Twitch or YouTube Live, you've used RTMP. And the reason RTMP is so darn reliable is because it's built on a foundational protocol called TCP. Now, the easiest way to think about TCP is like sending a really important package with tracking and delivery confirmation. It might not be the absolute fastest way to send something, but you're guaranteed that every single piece of that video arrives, and, crucially, it all arrives in the right order. For this first step, you're not going for raw speed, you're going for perfection. You need that guarantee.
Okay, our perfect video stream has arrived safely at the server. But now the real challenge begins. Taking that one beautiful stream and preparing it for millions of different viewers, all at the same time.
This just illustrates the problem so well, doesn't it? You've got someone watching on a giant 4K TV with super fast internet, someone else is on a laptop in a cafe with that sketchy Wi-Fi we've all experienced, and a third person is on their phone with just one bar of service. You can't just send the same massive video file to everyone. It would be a disaster.
The solution is a genius technology called adaptive bitrate streaming, or ABR. Honestly, this is the magic that makes modern streaming possible. Before ABR, services just had to guess what kind of connection you had. They'd send one file, and if it was too big for your network, it'd buffer forever. ABR was a total game changer because it stopped guessing. It creates a whole library of different versions, a 4K version, a 1080p version, a 360p version, and lets your device pick the right one. It makes the stream adapt to you, not the other way around.
So how does a system juggle creating hundreds of these versions at once without missing a single beat? It's done with this incredibly clever architecture. Think of it like this. A manager service gets the video and creates a big to-do list of all the versions it needs to make. Then you have an army of worker servers just watching that list. The second a job appears, a worker grabs it, does the conversion, and then places the finished file in a shared digital warehouse. It's massively parallel, and it can scale up to handle pretty much any load you throw at it.
So the video has been received and transformed into hundreds of different versions. We're almost there. But now we have to make sure every single one of those versions is perfect. And that requires a constant, watchful eye over the entire process.
To do that, we need to understand two very different but related concepts. On one hand, you have quality of service, or QoS. That's about the network. Can the pipes deliver the data? But then you have quality of experience, or QoE, and that's what really matters to us. It's a measure of what you, the person watching, actually see and hear.
You can have perfect QoS, but still have terrible QoE if the video itself has ugly blocking artifacts or the audio keeps dropping out.
So how do they monitor for both? This diagram here shows the entire workflow and highlights 4 crucial monitoring points to ensure quality from the very beginning to the very end. Let's walk through them.
The first half is all about content preparation. At point 1, the system checks the raw video coming in. There's that garbage in, garbage out principle again. Then at point 2, after all those versions have been created, the system actually verifies the quality of each individual profile to check for things like overcompression or other visual flaws.
The second half is all about content delivery. At point 3, it checks the main origin server to make sure all the video files are ready to go. And finally, at point 4, it monitors the Content Delivery Network, or CDN. Those are the servers closest to you to check for things like latency and load times, ensuring a smooth final delivery right to your screen.
And that brings us to the end of this incredible high-speed journey, from a single camera to millions of screens, all happening in the blink of an eye.
So, to recap the whole journey, it starts with a perfect ingestion using RTMP. Then it's transformed into hundreds of versions using that clever manager and worker system. Quality is monitored at every single step of the way. And finally, the perfect version for your specific device gets delivered right when you need it. This whole system, the ingestion, the transformation, the quality control, and the delivery, is the real unsung hero of your streaming experience. It's a massive, complex, and elegant solution to a universal frustration, all working invisibly in the background to make sure you never see that spinning wheel.
You know, this system perfectly solved the challenge of delivering pre-shot video, but it leaves us with a fascinating question for the future. What happens to this carefully planned journey when the videos themselves are being generated moment by AI? How does this pipeline adapt to a world of infinite real-time content? Now that's something to think about.